All right, thanks for coming, everybody. If you're not a core committer to Hadoop and you want to speak at a big conference, you got to come up with a catchy title to get folks to show up. So hopefully the content will keep up with the catchy title. But it's titled Mutable Data in Hive's Immutable World, kind of a little play on words and the technology itself. And if you read the synopsis, just to make sure you're in the right place, we're going to talk about the notion of, I use the phrase active archive, but data replication to some level, at a casual level of relational systems into Hive. So we'll move on. Before we get started, always, everyone has to give you the intro slide. I'm the only Lester at the show, not just the only Lester speaker. I'll throw this slide up at the end at questions, just in case there was some interest. You want to catch up later with me. And all topics have to have some background or remind us of stuff, so this is hopefully very fast, but information that I'm making the assumption that most everyone in here knows. So Hive's sweet spot has been that time-based, non-changing data we all have talked a lot about historically and probably are still talking a lot about now. And examples, of course, are weblogs and things of that nature, but people like to say IoT. I think I only heard of IoT a couple months ago. I'm kind of slow, but we were doing a lot of cool sensors, patient data and others, and a lot of these companies are either here or have been their logos and stuff splashed around. Some of the kind of interesting data I've seen is like aircraft data, helicopter data from Bell helicopters. Very hard to kind of do some analysis after the fact on, but very cool data, interesting to me. And then, I think Mercy is here and talked about their, pulling data out of their medical record system. In fact, much of their talk was did some of these earlier strategies, and then they had to go beyond to solve some specific problems that they had. But there's an outfit in Atlanta that works on children, that focuses on children, and they're looking beyond just, what's your blood pulse, your pulse, and when did you get a shot. They're looking at, how cold is the room, how hot is the room, how bright it is, how many people are visiting you, are you watching TV, are you playing, and really just looking for those minute levels. And again, I think that's been the theme of the conversation here today. And of course, we all know we've got phones that hold a lot of information and share it out there. So if that was the type of information that we call the sweet spot of Hive, just to refresh again, why? Well, because Hive can and Hadoop can technically easily can add to additional data without a lot of problems. And if we're talking about Hive, we're talking about partitions. And again, I'm making the assumption everyone understands that. It's going to kind of be germane to the conversation in a minute. But if you're not 100% there, partitions are just another way to, maybe in Hive's terms, not maybe in Oracle's terms, partitions are another way just to put some more data on and some more data on. And I think that little visual is trying to explain, just putting another chunk on the side. And if you do that, and that partition strategy really aligns with what kinds of questions you ask, at least your qualifying questions like where this is this, then you get the opportunity for, instead of looking at 62 petabytes of data, maybe you're looking at a petabyte and a half to solve a question, and those partitions come to place. And again, the larger Hadoop ecosystem and base tools, in our context, Scoop is a very useful tool, has some nice levers to help us get that kind of information quickly in there. So if that's the backdrop of what it does well, what are we going to talk about in here? So we're going to talk about, and hopefully we'll hang around after this use case definition, what if you had transactional systems, and I don't want to say OLTP databases or OLAP databases, but transactional systems of record of sorts, kind of piggyback the keynote conversation. That could be there's supply chains and all that stuff, but order entry systems, et cetera. And that information obviously is making changes. And what if your use case was not to think a little differently, which is probably the better answer. It is a different technology, and I would not say the better answer is to think about those systems to be a series of time series immutable information. An order was created, an order was changed, a shipment was made, a customer had the wrong zip code, they told you. Arguably the better answer, and the answer you're going to evolve to is, and maybe do simultaneously something like this, is to rethink what you're doing and re-look at your data, but look at your events of those data and turn that around to let the tools do what they do really well. But that said, the use case we're going to focus on is what if you just wanted to have that database name, those table names, those column names, those data types to represent. And the real use case that I see, and some of my customers were that it's that low corner one we just talked about in the keynote. They may have 10 or 12 of these systems, and they may have analytics lined up for each one of those, but they don't have yet a way to cross-pollinate that. So that's really, while it's low-hanging fruit for a lot of folks, that's where the value is today in Hadoop, at least to get them started. So I don't want to discourage that. All right, so we'll jump on in. How do you do all this? Well, you start out with something very unexciting and see if it works for you. That's my theory. So no rocket science. I won't spend a lot of time here. But if your data is really of a certain size, likelihood of those simple tools like Scoop and just basic Hive could very quickly get the information in your systems back into Hive and off and running. And in fact, not just to initially stand them up, but to account for the fact that they are evolving, they are changing as you go along. So you probably in this use case decide that I forgot to mention, let me say it on a previous slide, if I can go back. There we go, sorry. That I'm terrible with this tool here. Wow. That last bullet, I want to make a point on that, is not going to try to build a system that follows like a trans log and gets every single event. We're just saying point in time. So if 15 minutes or an hour and a half, whatever that answer is for you is good enough, then these strategies will make some sense. So again, kill and fill, slurp and burp, whatever you're going to call it, the old full refresh makes a lot of sense. And in fact, very easy to kind of build your own little homegrown framework of sorts, open a connection to the target system, read some metadata about a database. You could handcraft it all, or you could automate a small framework to do this for you within a really short period of time. And it'll get you pretty far. It'll get you very far. But at some point, it won't. Those systems will have a few tables that are very big, have a lot of tables that are very small. And at some point, the period of time to take that information and to slurp it and change it took longer than the period of time that you wanted to refresh. So what do? Logically, you just start doing some kind of merge and replace. So these are kind of the steps I see a lot of folks go through as they walk into this. And again, keep it as simple as you can. This model, again, there's no real rocket science per se yet. Go to that source system and say, what's changed since the last time I was here? What's changed since the last time? So you call that maybe your deltas. Data processing 101, take the big, take the other one, merge them together, replace it and move off. I think the kind of call outs that I put at least twice in there where the reality though is, while that picture looks like maybe the sun is your existing data and maybe the deltas are the size of a big Jupiter, I think the sun's like a really big sun and your changes are probably like Mercury or Earth or something. So with that in mind, and if this data is big enough, even that's not gonna, stole jump forward at one slide. If you go down that path, it's a tiny bit harder, not much harder than the slurp and burp, the full refresh pattern. You need some information to help you with that merge. Obviously, you need your relational systems. Hopefully, arguably, all those source tables have some kind of primary key that you can use as a unique index to leverage a couple of strategies we can talk about at the end. If that's not the case, less than I ever imagined, many systems don't have this notion of just a simple last updated timestamp on records. Couple easy strategies, they all usually involve triggers, maybe an additional column or maybe another table if your DBAs can accept the trigger but can't accept changing the tables, then ways to get there. And again, use something like Scoop. Doesn't mean that's your only answer, but it's an answer that gets you pretty far. And the Scoop has some nice tools that kind of piggyback on that concept to build that Delta file. How do we do that? I threw this slide up. We kind of talked about how we did it, but I did want to reference this blog post on the bottom there if you haven't seen it before on the Hortonworks site. It's a year old, and it was done all in Hive. But it talks about that full merge and replace and gives you a top to bottom, working example should you want to go back to your hotel tonight or work on Monday or whatever it is and try to reproduce. Used a few different words than I did, but it's the same thing. Get the information, coalesce it all together, swap out the underlying table with that information, and move on. You Butterfinger, and the battery came out, of course, but you're not limited, obviously, to use Hive and something like that, as the example shows. I'm good, thanks. I think. There we go. And some of us like other tools. I like Pig as much as possible for some weird reason. A Java programmer that likes Pig, but ultimately, just like the full refresh, that process, that model probably won't make it forever. You're going to hit some point where even that process takes longer than the period of time that you want to refresh on, and it's not hard to imagine why when you think of the sun and the Earth. If I got to look at every piece of the sun just to find out, yep, nothing's really changed for high percentage of that, then it's kind of easy to imagine how it's going to be there. But again, I'm advocating do the simplest solution you can. And in fact, if you look at across say you're looking at 30 or 40 databases or 10 or 12 databases, and each one of them have 50 to 150 tables, start out trying to do everything an easy way, and then find a way to start. Okay, well, these few tables do this, these few tables do that. But so if the elephant's too big, how do we ultimately get there? It's Hadoop. We parallelize. We go at the problem in slices as much as possible. And if that's the case, I was trying to set the stage for that a second ago. If that's the case, if there's a better answer that says go at it slices, then why not just start there for everything? Because of the KISS principle, because it does take effort, does take some planning, does take some data profiling to get to these answers, and you have to have some characteristics that are there today. So you could do this, but I would suggest, again, do as simple as you can to solve the problem that you have. And just like the full merger in place, you need to have some additional kind of things you need to make sure your data, it can do well for you. And arguably, if you can't imagine where we're going, we're gonna lean on those partitions really quick, and we need to make sure the partitioning strategy that we're gonna use for this table will handle the archiving process that we're gonna do. Good news is, chances are that that partitioning strategy will be very similar. Likely be the same strategy you would have done just looking at the data itself. But just to reiterate, the partitions, you need to have something that you can hang your hat on. It's always going to be there. It's not going to change. Like a good partition, you're going to add, primarily you're going to be adding more things to the tail end of that information. And then the characteristic that's kind of special here or makes this process not work well if it doesn't, your data that as you're looking at and profiling it, is the deltas you would start to expect should be skewed. Most likely they'll be skewed closer to the data that you've recently added it, but it just really needs to be skewed in such a way that only a certain smallish percent of your exhaustive table behind the scenes actually needs to be changed. So again, you'll probably see if you do use the old date created or some kind of derivative of that event that you hang your hat on, that likely the things you added today are changing a little today. The things you added yesterday are still changing. And then depends on if you're an order entry system, if you're Amazon, the events probably die really fast. I don't know about you guys. Those packages sometimes show up I think they're going to say in Atlanta they're going to show up today, which is interesting. They usually show up tomorrow. So a lot of that could fall off. But if it's a patient system, while you might go to the doctor and you think it's over, chances are you took a lab result. So that usually is measured in maybe a couple weeks. If you go to the hospital, my gosh, I hope you get out of there in a couple days, if not a couple hours. Myself, been there a few times. So, but again, the whole mission is we want to be able to update a small percentage of the overall system. If not, if you don't have this characteristic will fall apart. And I do challenge anyone, if you have a cool domain model and a cool use case that ends up, like every 15th partition is the one that gets changed, email me, or reach out to me. I'd like to understand it better because, again, I just see those humpback whales, the old RUP model, if you remember that, when you look at it on a piece of paper. Killed the battery. And all that picture is showing is what we just talked about. Most likely, the things you just added, and if I'm using date today, probably changed a little bit today. Some more things were added today, but maybe yesterday, smaller and smaller and smaller. So in this model, will probably be done changing in another 2 or 3 days where we really have no changes. So what's, how would you attack that problem? So arguably, it's the same way you attack the merge and replace that we saw earlier. Except you need to do a little housekeeping up front. You need to find out, which ones of these partitions would I target, some kind of merge and replace. I'll have some semi-working code in here you can use. You can reach out to me after the fact if you have trouble making this work. But get the mass deltas that you have from that, figure out which partitions need to be changed, and then just iterate through them either sequentially or depending on what kind of driver you put together, maybe multi-thread that information, and then ultimately replace them bits and bits at a time. So, they give us 40 minutes. They say be done in 30 minutes, so you can ask questions. So I purposely decided we were not going to do a working demo, but I'll try to show you some code that actually works, and you can plug it in back at your desk. And again, I some reason like Pig, even though I'm going to point out a few problems where Pig doesn't fit really well in this scenario, but hey, give it a try, try to make it work. So in this quick example, just try to give you some backstory. What if you had in one of those target databases, you had a table called Bogus that did have a nice ID that we can leverage, a couple of fields, and in our case, we decided it was partitioned by dates. Awesome. If you were paying attention really hard, I don't have a last updated timestamp because I only have so many rows in the slide and I wanted to keep it clean, and we're not going to actually do the scoop export, so I'll cheat that. So you get a table, don't tell me I blew it up. Okay, there we go, we're good. Again, this is one-time event. This isn't that process. This is that stand it up the first time. Get some data, whopping 9 records that spanned about 3 days, 17, 18, and 19 last November, some values, load it up. I'm just going to use, I'm going to use Pig to load it up. Did I look at it right? Yeah, so I'll read it. I'll total order sort it, and I'll shove it into the table via HCAT store with Pig. So that was some backdrop. There we go, I'll do a quick select. The table looks the way we expected. And if I looked under the covers, as expected, we had 3 partitions that were created, all good. So we got our backdrop. So that said, again, I'm simulating the Delta file generation process. So in this case, we might have used Scoop. And Scoop kind of told us, hey, here's what's changed since the last time we saw it. And if you notice, we're following a pattern of maybe 3 new adds a day, big system. And in fact, we didn't have any changes on the 3 records from the previous day. We had a couple 2 from the 18th and 1 from the 17th. I'm going to hone in just to keep the example really simple that 9/17 is my birthday. I was born in 2014. I'm a young man. There we go, thanks. I needed that. And you'll just remember that the only thing that changed in that record was that middle field. So we get that Delta file, and again, I'm going to use phrases like from that determine what deltas, what partitions are affected that need to be worked on. Not take Lester's code and trust him that he did it right. You can do it your way, but conceptually, what are we trying to do? I'm going to read that file, I put it on HDFS, and ultimately, I'm going to build a file that I decided to call, affected partitions that I put back on. I put back on HDFS. Maybe that's not the best answer always. What I didn't do, in case anyone's noticing, I didn't split that file out by partition. You could do that if you wanted to. I didn't want to write the information twice, my call, but your mileage may vary some. And now that I know I've got this large Delta file and I know the partitions that I care about, what do? That's what we said a few minutes ago. I need to work through that information, each one of those affected partitions, independent of each other. And the kind of gotcha here is that I like Pig, but Pig isn't Java, so I can't just iterate through that list and do cool. And everybody's, we got a for each. Well, yeah, but you can't do what I'm trying to do here. or you guys can call me afterwards and let me know what I did wrong. PIG's got some basic things that help you there, some integration points through control structures you can explore. But for this example, if you were really going to automate it, I would just put a simple script together to kind of iterate through or loop through top to bottom those affected partitions. So some of the dirty secrets. Once you did that, since I did not break down the Delta file into a bunch of smaller Delta files, I have the big one, I have to open it up. I have to quickly filter on that from the partition that I was handed to take care of. So we'll call that information Delta P. I am a Java programmer, those are terrible names, but font's big, this space is there. So Delta P is a list of the deltas for the 17th. In fact, so that's one record. I'll also in Pig open up make a connection to the Hive table, filter on that same partition, and I'll hang on to that partition's level of information. I'll call that table partition. I have table information for the 17th, which is 3 records, Delta information, which is 1 record. And then I'm going to merge it now. When you get my slides, if you want to see the full implementation, it'll be in the notes. And again, this is what I said a minute ago. I'm just telling you need to merge that information. There are tools that do merges. There are other ways to do merges. A simple way to visualize, though, is now that I have those 2 larger collections, just join them together in such a way that no matter what, everyone will be accounted for. So what's going to happen is, if you'll bear with me in my hand here, this is I'll call it four fields that each ID field 1, 2, and 3 exist. And when I merge those together, the reality is on my right-hand side, I'm going to end up with anything that came from the Delta file will be present here. And if it does align with something from the database, great, it's lined up. But if it's something new, then the stuff on the left is empty, great. And if they didn't change, then it would be on the left-hand side and there'd be nothing over here. So sounds complicated, but it's not. And then the decision-making process is really straightforward. Look on this side over here, if something's present, it wins, it trumps, if not, default back. And when you do that process, and again, you can see it in more detail in the notes, if you do that process, what does my slide say? I guess I thought I showed it, but if you do that process, you ultimately are going to get the changes and the additions that have happened. So anything new that came in and anything that changed that came in. Hang on to the delete for a second. In this case, what do you want to do with that file when you're done? That's your new partition level information. Another bad thing about Pig, I can't do like an insert overwrite on a partition. So in my somewhat kludgy example that I'm showing you, I'm going to hang on to that information one more time. I'm going to write it off to disk and say, whoops, I have to take care of it differently. But by having it on disk, I can show you, in fact, that's what I'm going to replace the 17th partition with, where that 1 record, number 12, did change that 1 value. And use a tool that can easily drop a partition. Maybe I'll just ask Hive to knock it out. And then I'll just load it back up. And again, I'm pushing Pig for some reason today. So read it, store it back into the environment. So there's probably some logical questions coming up. I will talk about them, but definitely hang on to them if I don't. Some consistency issues that you're probably asking yourself about. But that said, if I did a select all in that table, and then the 917, there's the change, it happened. And if I did all of that and it made perfect sense to you, then great. It probably made perfect sense, but you probably thought, wow, that was a lot of effort just to change 1 record, Lester. And yep, it is. It's a little bit of a painful one. And we'll talk about Alan Gates' presentation for Monday in just a moment, why that might be something that makes your day. But definitely get back. It's only day 3, but I'm tired. I know y'all are too. Get back, get caught up on work. If some of this resonated with you, look at it again, see if there might be some thoughts, questions that you want that you might be able to leverage. That said, if I look at the time, 15 minutes left, I mentioned under my breath that process that I implemented didn't take care of deletes, and it didn't take care of deletes because the way scoop goes to the source, and if it's not there, it doesn't know. My mileage in my 22 years working for large companies building CRUD systems, create, retrieve, update, delete systems, no way deletes anything. So that may not be such a problem in your world. You might more often do more of a state engine that says things have they've kind of hit end of life, but they're still persistent. But if needed to be, there are some strategies. You could, much like the trigger I suggested, you could put an on-delete trigger, maybe build another table that shows those, maybe just that primary key, the date deleted, and then use kind of an import again from Scoop to pull that and process that separately. Or if the data supports it and you want to do this, maybe every once in a while you just kind of go back and say, hey, you know what? On the second Tuesday, the third Tuesday, every other, twice a month, I just kind of go back and kill and fill. There's no universal answers for all this. Your data is my data, and everyone's data is different. Your domain's different, so unfortunately, there's a lot of questions you have to ask and make decisions upon them. I kind of gave you 3 scenarios, right? A full refresh, a full merge and replace, a partition merge and replace, and just for fun, I'm a big fan of Battlestar Galactica, old and new. So why not have a hybrid approach? And a gentleman actually walked me through this, why this made sense at a customer of mine, one of our sales SEs challenged me, why wouldn't you just do this under this scenario? So we had a scenario where those partitions, of the affected partitions, almost high percentage, 80–90% of the records were churned over. And so as we worked our tail butt just to figure all this out, and then at the very end, they quickly died off. And in our case, we decided there was a scenario where n number of partitions, whatever the partition is in your world, if we would just always go back that far and just get all of that level of information and just swap that out, do a full refresh on the full partition, and in fact sped up that process for us. But the consequence obviously is anything that's n-1 beyond, and you lost it. But that may work for you, either because the data never will change, or because the old adage of Hadoop, or big data, close enough is good enough in some scenarios. So there we go, pretty straightforward. So if you put all those strategies together before we talk about all the fancier stuff that Hive's given us, then I would say you could use this not as a scorecard or a true decision-making process, but as a kind of a relative, just heuristics to help you see where this might make sense from you. And in fact, if I didn't say it clearly enough, I'll say it again. Chances are a lot of the tables in this database that you're trying to replicate, that full refresh will satisfy. A few more of those that full merge and replace might, and then a few, the large few, this partition level merge and replace will be your winner. And in some cases, if you guys went to the Mercy conversation, which was a customer of mine, they had some even bigger dreams, and they, since I left them about a year ago, actually, Adam and those guys built that out. They built something that has the little bolts on the side, but it works for them. Wow, that was a tough crowd. It works for them, and but I don't know if I'd recommend it general purpose that everyone go there. Your data, your use case, your example gets there, and as I said a minute ago, sometimes this stuff hurts. Maybe in 3 years, it won't hurt like this, but it hurts like this today if this is your particular problem. And there we go. So as you get to the really big tables, the really big tables, that's when those partition ones really make a lot of sense. So let's talk about something more advanced than old school, pragmatic. How do you get this done? Surely there's something that's going to make this a lot easier for us. And I hope if you came to this session, you probably went to Alan Gates' Prezo on Monday, and you probably have followed that theme on 5317 for a while. The reality is that that is a much more elegant solution at heart than anything I presented. The truth is that solution is much more tightly coupled with what I presented here. The truth is that folks that have done what I've talked about here for a while now feel somewhat vindicated that the solution that's really under the covers is a lot like what we just saw, but just getting it out of your hands. But the real win is that because they're controlling that, they can resolve those hazard windows that I didn't talk a lot about. Just throw the partition away and put another partition up. Well, for a little bit of time, I had nothing in that partition. And I've got 2 choices, either have twice as much or have nothing for some period of time. I like to go for have nothing, but So it takes care of those situation forces, but it also makes you look at the problem differently. And as Alan pointed out you listened, and if you tried some of this stuff, these aren't the exact inserts and updates that we remember, because Hive doesn't have a primary key, and things can go a little awry if you're not careful. You can do an update that you think is going to happen, but because you didn't target the right partition, nothing happened. Or you can do an insert, and if you didn't really kind of make sure you declare where it needs to go, you might have inserted it once in all the partitions. So a lot of things that can happen, but the real driver is you need to go back to a row level conversation as opposed to a data set conversation. So you're thinking at an atomic level, of a partition versus a record. And they're all good, it's all right, you should march forward. I'll tell you some reasons why you maybe don't just get there originally, but I would say start there. Give it a try, see if it solves your problems. It may today, and if it doesn't today, it probably will very soon. There are some commercial off-the-shelf solutions that I've seen kind of come and go behind the scenes in the last couple of years. I haven't seen one that really hits perfectly. Purposely didn't put those names up here because I call them failed experiments myself. But those that follow Hive pretty heavily, there's this streaming data ingest. And as the gentleman from Mercy said, I wish he told me before he tried. He said, in the fine print, I should have noticed it said this is inserts only. There is some active work in this space, and Alan did talk about that. I think it's 10165, the Hive JIR number. Gentleman Eric, someone that's working pretty hard on this. So, but those are still months, if not a little longer away. So, things to consider. Things are always getting better. Again, just some more points on 5317, insert, update, deletes. You have to say it 1,000 times. It does not make Hive a relational database management system, even if you think it does. It does not. And I think he was really taking it from the perspective, don't put this behind your order entry system, but I would also challenge to say the operations are subtly different. They may, we just don't have a primary key. So there's just many things that we don't have in Hive that we have in RDBMSs. Hive 14 and beyond came out in December. That sounds like no big deal. I work for customers that are in finance and other places, and they take their time. They're risk adverse to make upgrades, so it takes them a while to get benefits. There's some changes, some requirements around data definition, partitioning for sure you have to have in place, and bucketing. And if you read the fine print, non-sorted bucketing. And since I'm running out of time, I'll save that if anyone has a question, or afterwards we can talk about why. And today's only supporting org, so while I work for Hortonworks, that's an awesome thing. There are other people that maybe are looking at other file storage technologies that are coming, but they're not there today. And then ultimately, I don't want to make a dig against the performance, but what I mean that is everyone's cluster is different. Some people have 8 nodes, and some people have a lot of data, and some people have, so your mileage will vary. So I'm encouraging you to, in fact, explore. I'm encouraging you, if your exploration shows that it works great for you, make your life simpler. But if not, try to give you some strategies that have been used for a number of years now by a number of people. And they're base level strategies. Many people have turned those, and again, put bolts on the side. So if I wrap it up before some questions, I would say, again, go back. I hope it was a good conference. I've had a lot of fun. The folks that are pulling together in the back of all these rooms are doing a great job. But digest this stuff. If any of it resonates, like I said, take another look at it. I'll put my information on the screen. You're welcome to reach out to me. But it's Hadoop, and while it's a 10-year-old technology, it's still new for a lot of folks and new for a lot of scenarios. So you have to try a lot of things. And when you get a good answer, you have to try again in 6 months, or when you change something, because the tech changed and things change, your assumptions change. So try, find the best answer that makes sense for you. Make it as simple as possible when you can. And I encourage you, and it's not that it means to go to your local user group, but I've worked in organizations that people don't talk to the person over the cube wall. Talk to people, people tell you what they're doing. So socialize, collaborate, and 100%. Look to Hive, look to the Hive community. I mean, if you really follow what has happened in Hive in the last 2 years, incredible, but continue to expect even more great things. And that's it for me. If there are any questions, take them. Thank you.